Hello guys, today we are going to solve this problem, minimize the difference. So let's read the problem statement. We are given an array A of length n consisting of only positive integers and an integer k. So we have to update every element by increasing or decreasing that element, and our task is to minimize the difference between the maximum and the minimum element. So let's understand it by an example like this. We are given 1 2 3 4 5. So what is the maximum element here? It is 5 and minimum element is 1. What's the difference between them? It's 4. So we have to minimize this 4 by adding or subtracting what k is we are given 2. So we have to add 2 or subtract 2 to each of this element and get our minimum difference of those elements, the maximum element and the minimum element in in that case. Okay, so let's understand the test case much more better. Okay, so what we are given, we have n equal to 5 and k equal to 2, and we are given an array 1 2 3 4 and 5. So we can see here that uh, it is a sorted array. Okay, now we can see that the the difference here is 5 minus 1, as 5 is the maximum element and 1 is the minimum element present in this array. So our difference become 4. What we have to do is minimize this difference. We have to minimize this difference by adding or subtracting 2 in each of those elements, and it is necessary to do that. Okay, so it is compulsory to do that. Yeah, and every value should remain non-negative also. So we can't subtract a number, like we can't subtract 2 from 1. We can subtract 2 from 2 because it is a non-negative number, which is 0, and we can subtract 2 from 3, 4 and 5 as well. Okay, now we have to minimize this difference. Okay, we have to minimize 4. So what we can think is, we have our maximum here, we have our minimum here, and we have to minimize the difference. So what we should do, we should absolutely decrease 5 and we should increase our 1, so that or we can say we should increase or we should decrease our maximum, we should decrease our maximum and we should increase our minimum, so that the difference of these two becomes the minimum. Okay, so we should decrease 5 and we should increase 5. So what we can do is subtract 2 from 5, which will give us 3, and add 2 in 1, so that will also give us 3. Okay, now we can say that we can do this, but it is not there, like we can say it is not always a case, like we are subtracting 2, so it is not always the case that 3 is will be the our maximum, because we have to perform the operation on every element. Like if I am subtracting 2 from 5 and I am subtracting 2 from this and 2 from this, then if in such some case I add here 2, so it will result in 6, which will be the maximum. Okay, so in some case I might add 2 here and subtract 2 from this, so it is not compulsory that the subtraction will result in the maximum number. Okay, or there might be a case like I if I didn't have 4, let's say I don't have 5, so if I 5 was not present here. Okay, so what will be our difference? It will surely be 4 minus 3. That would be 4 minus 3, that no, 4 minus 1, that would be 3. Okay, now if I subtract 2, that would become 2. Okay, now I have two possible things. I can I can add 2 or subtract 2 in 3. So if I subtract 2 in 3, that will result in 1, and if I add 2 and 3, that will result in 5. So if I'm going to take the case of adding, that will be my new maximum, n- not this one which I got from subtracting. So this two which I am getting are not the maximum and minimum, but we are thinking that they can be a maximum or minimum. So we have to just check if there exists any pair of maximum and minimum such that the difference is minimum. So we have to find that only. So let's deep dive in some more example, or let's solve this one only and find the optimum case. And the best way to solve such problems are to go on and dry run on test case using our logic and see if we can find some pattern or something. Okay, let's find something. So I have now, what was the test case? I have now 1 2 3 4 5. Okay, now what I should do to minimize the difference? So what minimum difference now is, it is 4. I should minimize this difference. So to minimize the difference, I can add 2 in this. I can add 2 in this also. So what they are becoming? It became 3. It became 4. I can add 2 in this also. It became 5. Now what, I don't want it to maximize my already maximum number. So I should subtract 2 here and subtract 2 here. So what it become? It become 2 and it become 3. Okay, now what's the difference here? So here we have the greatest number as 5 and the smallest number as 2. So our difference become 3. Can I minimize it much more? So let's see, if I haven't added 2 here, instead I have subtracted 2 here, what it had become? It had become this 3, this 4, and if I had subtracted, this would have resulted in 1. Now if I have subtracted in this would have resulted in, let's say, 4 minus 2, it will same, and 5 minus 2, it would have been same. So what is the minimum, what is the difference here of maximum and minimum? The maximum number is 4, minimum number is 1, so our difference would be 4 minus 1, that is 3. So we can see that our difference is minimum possible difference is 3. Okay, now let's observe something. We can surely say that since it is in an increasing order, I will definitely, to minimize this, add in small numbers. Okay, so that my minimum numbers become big. So what our goal was to increase the minimum number and to decrease the maximum number. So this is our minimum number, so I should increase this I should also increase this. Okay, now this is our maximum number, I should decrease this is my maximum number, I should decrease this. Now there is a point, there is a line where we stop this, where we stop increasing and we start decreasing. So this point I can say is the point of inflection. Okay, so point of inflection is what? The point where we just change what we are doing. Okay, we can say that in easy language, that the point where we change or we rotate ourselves 90-degree is the point of inflection. So this is the point of inflection. So this can lie anywhere, like here it lied here, or here it lied here. Okay, so we have to find the point of inflection where our answer is minimum. Okay, we can also say that we have to find a point of inflection such that our answer is minimum. Okay, now here you can see that uh, at the point of inflection, the left number I am getting is my maximum, which is 5, and the right number I am getting is minimum, which is 2. Similarly here, at the point of inflection, the right number is 1 and the left number is 4, which are the maximum and the minimum at their position. Okay, so conclusively I can say that to solve this question, I should first get this array in increasing order. Why so? Because I have to find the point of inflection. So the second objective is to find the point of inflection. And the third thing is, if let's say I am saying that I have at index I will say that my I minus 1 will be added by k, and my plus, oh sorry, my I would be subtracted. So okay, so my I minus 1 would be added by k, array of I minus 1 would be added by k, and my array of I would be subtracted by k. Okay, would be subtracted by k. So since it is added by k, it can be my maximum. Okay, it can become my maximum, and none of other elements can become my maximum, because after this element they are getting subtracted. Okay, and if this and my array of I is getting subtracted by k, and if it is subtracting by k, it can become my minimum. Okay, like here and here, so it can become my minimum. So I can say it can become my minimum. So we have to take the difference of these two and check if what we already got is bigger or not. If it is bigger, then this can be our answer. So we will store it in an array. Okay. So conclusively, what we are doing, I've said that let's uh, understand a pseudocode of this. Okay. So what would be our pseudocode? We are doing nothing, but we will first sort this array. Let's say I'm given this array ARR, okay, and its size is n. I have also given k, so I'm saying that I have to sort this array ARR. Okay, so I will sort this array ARR using some standard template library function, or any way you can prefer, but I will do using standard template library. Okay. Next step is I would say what can be my maximum answer possible. So my maximum answer, or let's say call it answer only, maximum answer answer only, because we'll store our answer in it. We are initializing it with our maximum answer. So what can be our maximum answer? It would definitely be the maximum minus minimum at the particular case when we are given this array. So what will be the maximum of this array? It will be array of n minus 1. And what will be the minimum of array? That would be array of 0, as we have sorted it. Okay, the next step we can say what would be the next step we can say is, let's roam. Okay, let's roam in this. So since we have discussed that we are going to take array of I and array of I minus 1, so to so we are taking array of I minus 1 in our code, like, so we are solving that. So we should move from 1 to n to prevent the errors we can get, like array out of bound error. Okay, so we are roaming from 1 to n, and there what we are doing is we can say my temporary minimum number will be my temporary minimum number will be minimum of my already minimum number. And what is my already minimum number? It's array of 0 and plus k. And why so? I can say initially what I have said, like there is a case where I have to increase the maximum and decrease the minimum. I have said that. So this is the minimum. I have to increase this. It became 3. This is the maximum. I have increased it. Oh, sorry. I have decreased it and it becomes 3. So this is what my uh, in one case, this is what my minimum can be, and this is what my maximum can be, but that is not possible in some cases also. So we are taking this as our initial value for maximum and minimum. Okay, so the minimum, t minimum, my temporary minimum is minimum of array of 0 plus k, or or we are taking the minimum value. So what can be the minimum value? It can be array of I minus k. Okay, it can be array of I minus k. Okay, now what can be my maximum value? My maximum will be maximum of array of n minus 1 minus k, which was the last element minus k. and we can say array of I minus 1, array of I minus 1 plus k. So we have seen that there is point of inflection. Before that we are adding k, and after that we are replacing k. So we have observed that this will be our maximum element in that case, and this will be, oh sorry, this will be our minimum element in this case, and this will be our maximum element in this case. So we are just checking that is it the maximum and is it the minimum, and if it's such, so we'll say that my answer is nothing. We want to minimize the answer, so minimum of answer comma minimum of answer comma t max minus t min. Okay, so we have got our answer. Okay, now let's handle some errors which can occur, like when we are uh, what we are doing here is uh, we are taking this and this. Okay, now we can say there might be some case when this is negative, and we can't take negative as we are subtracting. This can be negative and we can't take negative. So for that we will apply a for if loop, what if condition, that if this is negative, array of I minus k is negative, will say continue the loop, and when this loop be over we will get our answer. So let's code it. Okay, so what initially we did, we'll sort our a- array. Here I've been given a vector, so let's sort this vector. Okay, so we have sorted this vector. Now we want our initial answer. So what is our initial answer? It's a of n minus 1 minus a of 0. Now what is our initial maximum value? So initial maximum value is a of n minus 1 minus k. And what is our initial minimum value? Our initial minimum value is a of 0 plus k. Okay, now let's run a for loop for 1 to n. Let's increase it. So we need n because it is not provided here in the attributes. So let's say my n is a dot size. Okay, my n is a dot size. Now if as we have seen that if there is a case that array of I minus k is less than 0, in such case we'll say that we are going to continue, we don't want to follow along. Okay, we'll move to the next index. Now what we have to do, I will have a t maximum which will be the maximum of already present maximum, like this, comma, uh, my array of I minus 1 plus k, I minus 1 plus k, because we are adding k in all the elements before that inflection point. And what will be the my t minimum? T minimum will be the minimum of mini comma array of I minus k. Okay, what's array of I minus k? That's will be the minimum value. Okay, now what our answer can be? So our answer, this t max minus t min can be our answer. So we'll say if it is minimum, then already present value, it is our answer. So we'll say t max minus t minimum. Okay, so we have completed this. Let's return the value and let's check if this is correct. Okay, we have got an error that array was not declared. So because we have a here. Okay, okay, let's run again. Okay, we can't find minimum. mm, Minimum cannot be used as a function. Why is it so? Have I used minimum? Okay, I have used minimum as a variable here. That's why. Mm, so we have got our answer. Let's submit it. Okay. Yeah, it's got submitted. Let's talk about its time complexity and space complexity. So let's talk about the time complexity first. As we are sorting the array. Okay, we are sorting the array and array has n elements, so we can say that this time complexity will be O of log n. Okay, this time complexity will be O of n log n. Now this loop is running for O of n, so its time complexity will be O of n. This loops will be O of n. So overall time complexity will be O of n log n plus O of n log n plus O of n. So which is equivalent to O of n log n. Okay. Now this, what constants we are given is n reaching to 10 power 5. So if n reaching to 10 power 5, we can say that n log n is accepted here. Okay, because it will not be too large. Okay, now if we talk about space complexity, we are not using extra space other than storing these three variables, and since we are storing only three variables, so our space complexity will be O of 3, which can be said as O of 1. Okay, so this was the solution for this question, and that's it for today.